So our topic for today is effect of temperature, pressure and catalyst on a rate of reaction. First of all, what is a rate of reaction? A rate of reaction is a speed at which reactants are converted into products. Reaction occur when two reactants molecules effectively collide with each other having minimum energy and correct orientation. That time a reaction happens. Let's begin with what are the factors that affect a rate of reaction. First of all, there is a concentration of reactants, pressure, temperature, catalyst, nature of the reactants, orientation of reacting species, surface area and intensity of light. But we are going to mainly focus on pressure, temperature and catalyst. So first, let us begin with the temperature. So what is the effect of temperature on a rate of reaction? On increasing the temperature, the rate of reaction also increases. So the question is why? This is because the colliding particles will have the required activation energy at high temperature and more successful collision will take place. So the reason is that because when we increase the temperature, the rate of reaction also increases. Now this is a graph for your activation energy. What is the question arises is what is activation energy? It is the minimum amount of energy that is required to activate the atoms or molecules to a condition in which they undergo a chemical or physical transport. As the temperature increases, molecules start to gain more energy and move faster. Therefore, the greater the temperature, the higher the probability that the molecules will be moving with the necessary activation energy for a reaction to occur upon collision. Let's begin with the pressure. So now this is an image for your pressure. When you increase the pressure, the molecules among collide is much faster. As pressure increases, the gas molecule can have more collisions. So when pressure is increased, the rate of reaction also increases. Because when pressure is increased, there is higher frequency of collision, so chances of successful collision increases. And hence, the rate of reaction also increases. So higher the pressure, the faster will be the reaction. Pressure is seen in terms of gases, whereas concentration is seen in terms of liquids. Let's begin with the catalyst. What does a catalyst do? It is a substance that increases the rate of reaction without itself being consumed. Meaning, like the amount of catalyst you used before the reaction will be the same after the reaction. The amount won't be decreased. Now this is an example for your catalyst reaction. Here platinum is a catalyst. And this reduces to water and oxygen. Let's begin to question some answers. Okay, the first question is on increasing the temperature, it makes the reaction fast, slow or remains the same. So the answer for this question would be fast because on increasing the temperature we learned that it increases the rate of reactions. So the answer for this question is fast. Now let's go to the second question. Products will form faster if the particle size of the reactants are larger, temperature is decreased, concentration of the reactants are increased or the reaction is not stirred. The actual answer for this is if the concentration of the reactants are increased, the product will form faster because if we decrease the temperature, it will affect the product and it will be taking more time for the reaction to complete. Whereas If the reaction is not stirred, there will be imbalance of the particles, and the answer will be actually the concentration of the reactants increased, the product will form faster, because concentration is one of the factors which is involved in the rate of reaction. Now question 3. The dash states that sorry the dash states that atoms, ions or molecule must collide in order to react. The actual answer for this is collision theory and not the activation energy. Question 4. A catalyst is a substance which increases the rate of reaction, decreases the rate of reaction, or do no change. We have learned that a catalyst is something which increases the rate of reaction without it getting self-consumed. So the answer for this will be it increases the rate of reaction. And for the fourth and for the fifth one, I would like to get answers from y'all. I hope y'all submit this answer in the comment section box. Thank you. And here are some references y'all can refer.